So this is a video lesson for Chapter 9, Section 1, so the first section of Chapter 9. And this section is all about polynomials, specifically adding and subtracting polynomials. Now, before we get to polynomials, we have to talk about monomials first. So, what is a monomial? Well, a monomial is any number. It can be a variable, it could be a combination of a number or variable, like, for example, a 10 is a monomial, 5.5 is a monomial, a fraction can be a monomial, so 3 over 4, that's a monomial. A variable can be a monomial, so you can have x be a monomial. You can have a combination of a coefficient and a variable, so 5y, that can be a monomial. You can have an exponent be a monomial, so you can have x to the second power, that's a monomial, or maybe like a combination, maybe 3w to the fourth power. That's still all a monomial, and obviously negatives are fine as well. So you can have negative 4a, that's still a monomial. So it seems like a lot of things can't be monomials. What can't be a monomial? So those are all monomials, so I'll put a check mark next to that. Now obviously it's not the complete list, it's just what can be a monomial. So what can't be a monomial? This is not a monomial. Can't have sums or differences be monomials. This is not a monomial. A fraction is fine, but you can't have a variable in the denominator. So while a fraction is okay, you can't have a fraction with a variable in the denominator. You can't have variables for powers or exponents. So let's say x to the 8th power, that's a no-go, or 5 to the x power, that's a no-go. So can't have variables as an exponent. And you also can't have negative exponents. So 6 to the negative first power, nope. X to the negative third power, also a no. So those are the big exceptions for monomials. Let me write down the subtraction case as well. You can't have y minus 4. That's also, let me do another example of, let's say, 7 to the w power. So those, all of these are not monomials. Monomials, not monomials. So again, the big exceptions are, so the rule is no addition or subtraction between the members. Can't have a variable in the denominator. Can't have a variable as an exponent. And last but not least, can't have a negative as an exponent. So those are the kind of like the technically the 4 exceptions to the rule of being a monomial. So now that we have figured that out, that the bottom list are lists of things that aren't monomials and the top list is a list of things that are monomials. Monomials also have degrees to them. The degree is based on the power of that particular monomial. For example, the power is represented by the sum of the exponents of the variables of the monomial. So in this case, the constant numbers don't count, only the variable, and if there's more than one variable, then you'll add the powers to get the total degree. So let me show you what that actually means. So let me draw a line right here and write down degree over here. So for example, let's take number I don't know, 10. It's a constant, it's a monomial, but because it's not a variable, automatically has a degree of 0. That's the lowest degree monomial that you could have. Now let's take something else. Let's take an x. This is an x to the power of 1. Obviously, we don't write that power of 1. So now, this has a degree of 1. Let's take an x squared. It's a power of 2. Has a degree of 2. Now let's take this, xy. Well, that's still a monomial, because you can have monomials that have more than one variable. I didn't write that there, but that's not an exception to the rule. It's not one of the 4 exceptions. I probably maybe should number these as exception number 1, exception number 2, exception number 3, and exception number 4. So if it's not one of those 4 exceptions, it's a monomial. In this case, that's a monomial. Now, the degree here is not a 1, because you have to take the sum of the variables, and the x has an exponent of 1, y is an exponent of 1, 1 plus 1, that also has a degree of 2. What if we have to take something like 2w? Well, here the constant doesn't count. The constant only contributes a degree of 0, so only the w does. The w is the first power, so that's a degree of 1. Let's do a few more examples. How about we take 3w to the 3rd power? Again, the 3 doesn't contribute anything, but the w to the 3rd power does, so this is a 3rd degree monomial. We can take something like this. X, z, or z to the 2nd power. So x, z squared. The x contributes of a degree of 1, the z contributes a degree of 2. In combination, you add the degrees, it's a 3. So it's a 3rd degree monomial. You can take something like this. Y squared and x to the 4th power. The x contributes a power of a 4, so it has a degree of 4. The y contributes a power of 2, it's a degree of 2. You add the 2 degrees together in combination. This monomial is of the 6th degree. You can have again something maybe like this, negative 3m to the 2nd and b to the 3rd. The negative 3 is a constant. It does not contribute anything, or it contributes a 0, which technically doesn't contribute anything. The m contributes a 2, the b contributes a 3. This is a 5th power monomial, or a 5th degree monomial. So that's how you decide what degree the particular monomial is. So that being said, so that's kind of like a rundown of monomials. Let's take a look at what polynomials are. So polynomial is a sum or a difference of at least 2 monomials. So, for example, if I wrote this particular event down, let's say I wrote down 10 minus x. Well, that's now a polynomial. You have one monomial, another monomial. We have a difference between the two of them. So this is a polynomial now. And you can rank polynomials in degrees as well. I can say that this is 1st degree polynomial. The way you rank polynomials is it goes by the ranking of the highest monomial. No longer you combine anything, so no combinations for polynomials. You decide the degree of the highest monomial and you use that. In this case, the 10 is a constant, so it has a degree of 0. The x is a power of 1, has a degree of 1. That's the ranking, the highest ranking degree, so the entire polynomial is of the 1st degree. But if I give you something a bit more complicated, like 2x to the 3rd plus x to the second minus 5x plus 12. This is a polynomial made up of 4 monomials. Monomial, 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 monomial. And the degree of this particular polynomial, let's take a look. The 12 is the lowest here, it's a 0 degree. The 5x, again the 5 contributes to 0, the x contributes to 1, so that's a first degree monomial. That's a second degree monomial. Here the 2 contributes nothing but the x's to the third, so it's a third degree monomial. So that's the highest ranking monomial, so the entire polynomial is of the third degree. And you see how I wrote it? You write them by the rankings. The highest degree monomial goes first on the left side, and then from left to right you kind of order them. On the right side you'll have the lowest ranking monomial inside that polynomial. Let me show you another example. If I wrote this down right here, 15 x minus x to the third plus 3. And if I asked you to rank this in order and then tell me what degree this is, well, this is 0 degree, it's a constant. This is first degree because the 15 doesn't contribute anything, it contributes a 0, and the x is the first, so that's a first power, or first degree monomial. This is a third degree monomial. So if I were to rearrange this, I would write it as negative x to the third plus 15x plus 3. That would be, and this is third degree. Sorry, it came out small. So that's a third degree polynomial. And the last thing that I want to show you is how to add and subtract polynomials. So for example, if I gave you a problem like this, let's take a look here. Let's start off with something simple. Like if I gave you 8b minus 5b, well, it's a polynomial made up of 2 monomials, both of them being first degree. If you have a situation like this where they're both of the same degree and they have the same variables, so both are b, both are of the same degree, they're the first degree, then you can work them just like any other number. That is 3b. But that is a simple case scenario in this case. I can give you something like this. Let's say it's 5a squared minus 3 plus 8a squared minus 1. Again, you have to take a look at all of your monomials, see what degree they are and what variable they have. Variable a, second degree. Variable a, second degree. No variable, 0 degree. No variable, 0 degree. So you can actually combine these two. You can combine these two. Nothing stops you from opening up that parenthesis. There's a plus in front of it. So you end up having 5a squared, 8a squared, for a total of 13a squared. And then negative 3 and a negative 1, that's a negative 4. So that's the solution to that particular problem. If you a problem like this, looks complicated, but again, look at the individual parts. Nothing stops you from opening up this parenthesis because there's just a plus in front of that parenthesis. So you're combining a pair of polynomials here, and you have to look at the degrees and figure out if they have the same variables. So the only variable present here is the x, so that's taken care of. And then you have to look at the degrees. Second degree, first degree, 0 degree, 0 degree. This tells you what can be mixed together. Once you finish mixing everything, 3x squared and an x squared, that's 4x squared. X and 4x, that's 5x, and a negative 6, and a positive 10, that's positive 4.